Students, today we're going to be talking about rewriting equations and formulas. First off, let's talk about literal equations. Any equation that has two or more variables is called a literal equation. To rewrite a literal equation, all you do is solve for one variable in terms of the other. This equation has already been solved for c. In other words, c is alone, and it is in terms of r. Now, we're going to take this equation right here, and we are going to solve for y. And then it's going to be in terms of x. Now, as we do this, first thing we need to focus in on are what are the things that are with y. Those are the things we'll need to eliminate. We've got a positive 4x that will need to be eliminated, and we are multiplying by a minus 7. So those are the two things we'll need to eliminate. First, I'm going to start off with the x. I'm going to deal with things that can be added and subtracted first. So we are going to minus 4x from both sides. Now 4x minus 4x is going to be 0. Over here, we've got this 12 minus a 4x. These are not like terms, so I cannot subtract them, I can't add them, I can't combine them. So in the answer, I just leave them as two separate terms. I had a negative 4x and I had a positive 12, so negative 4x plus 12. This could also have been written as 12 minus 4x. The only reason I rearranged it is because I prefer to have my variable terms first and then the constant terms after. This is a convention of mathematics. It's kind of an agreed upon way. This is the way we like to write it. If you don't write it this way, it's not that you're wrong, but writing it by putting the variable first makes it easier to read. All right, so now we need to eliminate the minus 7. So in order to do that, we're multiplying by negative 7. So opposite of that, we divide. Please note the way that I did this division over here. I'm dividing everything by the negative 7. Not just one term, but all the terms get divided by the exact same number. Negative 7 over negative 7 is just going to be 1, so we got 1y. Now this, I can't really simplify it. 4 doesn't divide by 7, 12 doesn't divide by 7, so I'm just going to leave it as is. All right, next one. This one is kind of odd because we're trying to solve for w. We want to get w alone, but here we've got a wp and here we've just got w. Now why that's important is that these are not like terms. I cannot add these two terms together. And so I can't simplify that using something like combining like terms. Since they both have a w and they're both on the exact same side of the equation, what I'm going to do is use distributive property. Usually we see distributive property being used to multiply a number through. This time we're going to use the distributive property to pull a number out, to divide a number out, and that number is w. Now you can even see right here, if we were to try to multiply it back through, we'd have w times 3 is 3w, w times 4p could be 4wp. So still the exact same thing, however, now I've only got one w. So it's easier to get alone. It's hard to get w alone if there's two of them. Now, we just need to pay attention to what's the relationship. W is being multiplied by 3 plus 4p. Not just by 3, but by that entire statement. So in order to eliminate it, we need to do the opposite, which is divide by 3 plus 4p. If we do it to this left side, we need to do it to the right. Anytime you've got any number divided by itself, you'll just get a 1. So even though we don't know what 3 plus 4p is, we do know that 3 plus 4p divided by 3 plus 4p is just 1. So we have 1w equals a over 3 plus 4p. Now, Formulas. A formula shows how one variable is related to one or more other variables. A formula is a type of literal equations. We use formulas all the time. They're all over the place. If you've ever worked with area or perimeter, you've used formulas. Okay, so for example, this formula that we've got at the bottom, A is equal to pi r squared. This is the area of a circle. It's a formula that tells us how the radius is related to the area. Okay, so the way the radius is related, you take the radius, you multiply it by itself, then you multiply by pi, and that's what the area is. Now we're going to solve this one for r. It's already solved for a. This is solved for a in terms of r. We're going to solve it for r and put it in terms of a. So first, we write the equation. Now, I'm multiplying by a pi, and I've got r squared. First thing we're going to deal with is that multiplication. The reason I'm choosing multiplication is we tend to do the order of operations, PEMDAS, we tend to do it backwards. So whereas normally if we were simplifying this, we'd do the exponent first. In the solving, we're doing that backwards, and we're going to begin with the multiplication. Now, to undo this multiplication by pi, we will divide both sides by pi. Pi over pi is just 1, leaving us with 1r squared. And then we've got a over pi over here. Now, we're ready to deal with the square. Because this is squared, we need to think of the opposite of what squaring is. Opposite of a square is a square root. So we take the square root of both sides. Notice over here, I did not just square root the a. I'm square rooting all of it. Square root of r squared is just r. And then we've got r is equal to the square root of the area divided by pi. So now we've solved it for r in terms of a. All right, so let's look at a few word problems. A patio is in the shape of a parallelogram. So here we got our parallelogram. Its base, which is up against the side of the house, is 13 feet. So we've got our house, and that's 13 feet. The area of the patio is going to be 156 square feet. Now the height of the parallelogram is going to represent the distance from the house to the edge of the patio. So that right there would be our height. The yard is 26 feet deep from the house to the back fence. Now here's our question. We want to find the distance from the house to the edge of the patio. Now, we know how far it is from the house to the edge of the yard. That's 26 feet. We don't know the distance from the house to the edge of the patio yet, which is just h. So in order to find that, what we're going to do is use the equation for the area of a parallelogram. Because we've got the area, we've got the base, we just don't know the height. Now, in order to get an equation that'll tell me what the height is, I'm going to solve for h. We've got h times b. I'll divide both sides by b, so that now I've got the height is equal to the area over the base. Now that we've got this equation, we're ready to move to the next step, which is substitute in the values. We know the area of the parallelogram was 156 square feet. The base of it was 13, which means that the height was 12 feet. So we now know that this height right here is 12 feet long. Now that we know that, we're ready to answer this next question. How far is it from the edge of the patio to the back fence? Well, if the height here was 12, and to go from the house all the way to the back fence is 26 feet, we just need to subtract those. So 26 minus 12 means that the distance from the patio to the back fence is 14 more feet. Now we're going to rewrite a rewriting the formula for temperature. This equation right here is used to change from Fahrenheit to Celsius. So this would largely be used by American scientists who we largely measure things in terms of Fahrenheit. But if we want to communicate with those outside of the US, we want to convert all of our temperatures, all of our measurements from Fahrenheit into Celsius. So it's in the form that they recognize. And that's what we're going to do. We're going to solve for Fahrenheit. First thing, we've got this fraction that we're multiplying by. To eliminate it, notice what I'm doing. I'm multiplying by the reciprocal. So I just took the fraction, flipped it upside down. I'm going to get 9/5, or 9 times 5 is 45. 5 times 9 is 45. 45 over 45 is 1. So I just have 1 times f minus 32. Anything times 1 is itself. And so it simplifies into that. 9/5 c, I don't know what c is, so I can't simplify that any further. Now we're ready to move the minus 32. So we'll add 32 to both sides. As we do that, we get 9/5 c plus 32 is equal to f. So now we know what the Fahrenheit is. Well, we've now got an equation that'll take any Celsius and change it into Fahrenheit. So this equation just moves in the opposite direction. It's useful for a different situation, such as this. On a July day, the temperature at the peak of Mount Everest is going to be negative 16 degrees Celsius. Now, is this temperature warmer or colder than 0 degrees Fahrenheit? In order to answer this question, we would need to take Celsius, change it into Fahrenheit, then we can make that comparison. We've got an equation that does it because we just solved for Fahrenheit in the other problem. Now, first thing I'm going to do is substitute in Celsius. They said negative 16 degrees Celsius. I'm going to put that in. 9 times negative 16 will be negative 126. We're still dividing by a 5, plus 32. Negative 126 over 5 is negative 25.2. Negative 25.2 plus 32 is 6.8. So 6.8 is warmer than 0 degrees. So negative 16 degrees is therefore warmer than 0 degrees Fahrenheit. Now, let's talk about simple interest. Simple interest is they give you the exact same amount of money every single month or every single year, depending on if you're getting your interest monthly or yearly. And the amount of money you're going to get is going to be based off of however much your principal was, the money you started with. So here's some important information to know about simple interest. In this equation, I will represent interest. P is the principal. That's the money you deposited right from the start. R is the annual interest rate. It's going to be in a decimal form. Okay, they'll usually tell it to you as a percentage. You need to switch that into a decimal by dividing that number by 100. Next, T is going to be time in years, and here's our equation. I is equal to PRT. Now, what we want to know in this problem, well, we've deposited $3,500 in an account that earns 4% simple interest. So we know the principal. That's how much we deposited. We know the interest rate. The question is, how long will we leave the money in the account to earn $350? So this original equation is really designed for people to be able to predict how much interest they'll have after a certain number of years, that you put in your principal, you put in your rate, you put in the time, and then it'll tell you how much interest you'll get after all of that. We want to know, if we know our principal and we know the rate, how long is it going to take us to get a specific amount of money? So we want to solve for T, so we create an equation like that. We create an equation that'll tell us the answer to this question: how long, time. So we want to solve for t. Now we're multiplying t by PR. Divide both sides by PR. P over P is 1. R over R is 1. So we've got time is equal to the interest over the principal times by the rate. Now that we've got our equation that'll tell us how much time it'll take to get that amount of interest, we're ready to substitute. So first, we've got our interest was $350. Our principal, $3,500. Our rate, 0.04. That's the 4% as a decimal. We can go ahead and simplify that, and we see that it took 2.5 years to get $350 in interest. Get a word problem, get a word answer. You will need to leave the money alone for 2.5 years to get $350 in that account in interest. Okay. Next, we got Dan drove 330 miles at 60 miles per hour. So we got distance and we got a rate. Ryan drove 275 miles at 55 miles per hour. So once again, distance and a rate. How much more time did Dan drive than Ryan? Well, now the question is asking about time. We've seen equations like this before. This is the DIRT equation. In other words, distance is equal to the rate times by the time. Now, what we've got for both of them is we know the distance and we know the rate. What we don't know is the time. How long were they driving? So first thing I'm going to do is solve this equation for time right now. It's going to simplify the rest of it. So we got time times the rate. So we're multiplying, divide by r so that we can eliminate it. R divided by r is 1. So we've got 1t is equal to distance divided by the rate. So if we want to know how long they were driving, we use this equation. This is a nice simple equation that'll calculate how long someone was driving given their distance and their rate. So we're going to write for both Dan and Ryan. Write down our equation. Next, we're going to substitute. For Dan, he drove 330 miles at 60 miles per hour. Ryan, 275 miles at 55 miles per hour. So Dan drove for 5.5 hours. Ryan drove for 5 hours. So Dan drove 0.5 more hours than Ryan.